So in this video, we're looking at LeetCode 77 combinations. The problem statement is given two integers n and k, return all possible combinations of k numbers using 1 through n. So in this case, n is 4, so we have the numbers 1, 2, 3, and 4 to work with, and k is 2, which means we want all combinations of size 2. So n is 4, meaning we can work with 1, 2, 3, and 4, and k is 2, meaning we want all combinations of that size. So we can use recursion and backtracking to solve this problem. So we're going to have a loop where we plant the numbers 1, 2, 3, and 4 into the first position. And it's loop 1. And then we make a recursive call into an inner loop wherein we've planted 1 in the first position. And so in this recursive call, we can try a 2 in the second position, a 3 in the second position, and a 4 in the second position. In the case where we've planted a 2 in the first position, we can try 3 and 4 in the second position, and then this loop exits and we backtrack out, and we get here where there's a 3 planted in the first position, and we can try a 4, and then we try a 4 here. There's actually nothing we can do. So what's going to happen is our program starts, we plant a 1 in the first position, and then inside of a loop we plant a 2 in the second position, and then in the next iteration of the inner loop we plant a 3, and the next iteration of the inner loop we plant a 4. This loop exits, and we backtrack up here where we plant a 2 in the first position and a 3 in the next position inside of our recursive call. And then the nested loop inside our inner loop plants a 4 in that position, and then it backtracks and we plant a 3, and in this way we have all the valid combinations. So I'm going to use a helper function here where I pass in n and k, and I'm going to have a path and then an output set, and it's going to build up the output set and return it. So the implementation of this function is going to take in nk, our path, and our output set, and then our base case is going to be if we have a path length of k size, then we're going to add a copy of the current path to our output set and return. And the reason we're taking a copy is because we're going to mutate this path. So for let I equals s, which is going to be start I less than or equal to n. So looping from our starting number up to n inclusive and I plus plus, and s, our starting number, is going to depend on which scenario we're in. So there's two cases we can be in as far as s is concerned. This could be the first invocation of the helper function, in which case we want to start counting at 1. In the other case, this is not the first invocation of the helper function, meaning we already have something in the path. So in that case, we want to take the last number in the path and add 1 to it. So if we've already planted a 1 in the first position, we can't put a 1 in the second position. The first number we should consider in the second position is 2. If we've already planted a 2 in the first position, then for the second position we should start at 3, because we've already used 1 and 2 at that point. So if the path length is equal to 0, then we start at 1. Otherwise, we use the last number in the path in this way. And so we're going to do path.push I to put the plant the number in the path. So in this case, the first invocation of the helper function, we're planting the first number in the combination, which is going to be 1. And then we're going to do our recursion, and then we need to splice out that number. And the reason is so that after we've considered all the possibilities here in our recursion where the 1 is planted in the first position. Now we remove the 1 from the first position. We come up here in our loop and put the 2 in the first position. And then inside of our recursion, it's trying all the other positions, in this case 2, only 2 positions. And so here we're going to call our helper. We're going to pass in nk, our path, and our output set. And then down here, we need to return the output set so that it returns it up here to our driver function, combine, which is driving our recursion. And it wants an array here, not a set. So we're going to do array.from. And let's see if this runs. Okay, so we got 1 1, 1 2, 1 3, 1 4, 2 2, 2 3, 2 4. So I forgot to add 1 to the starting. So in the case where there is a number in the path, we don't want to start counting from the number that's already in the path. We want to start counting from that number plus 1. And let's submit that. And that's how you do the combinations problem on LeetCode. Thank you.